Hello class, today we're going to continue chapter 10, Geometry, with 10.5, Volume and Surface Area. So building off of that area and circumference we did last time. Objectives today are to use volume formulas to compute the volumes of three-dimensional figures and solve applied problems. Compute the surface area of a three-dimensional figure. So let's look at the formulas for volume to start with. The volume of a rectangular solid V is the product of its length, its width, and its height. So volume equals L times W times H. Volumes of box-like shapes, such as rectangular solids and cubes, are just length times width times height. In the special case of the cube, it's just side times side, since with a cube, very similarly to a square, all the sides have the same length here. So you could just take the side and cube it, and you would have the volume of that particular cube. Now, if you look at the figure over here in the bottom right hand corner, we have length of 3, width of 3, and height of 2. Okay, it's all made up of these cubic units here. 3 times 2 is what's going to give you the volume of this particular rectangular solid. So 3 times 3 times 2. 3 times 3 is 9, times 2 is 18. And what you can notice is if you count the cubic units within this particular model, it adds up to 18. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, just kind of filling it in as you add it in. You'll see that there's 18. That's how we get the volume, just stacking those cubes essentially. But we'll find it with multiplication. That's the easiest way to find it for a rectangular solid. Alright, let's look at solving a volume problem. You are about to begin work on a swimming pool in your yard. The first step is to have a hole dug that is 90 feet long, 60 feet wide, and 6 feet deep. You will use a truck that can carry 10 cubic yards of dirt and charges $35 per load. How much will it cost you to have all of the dirt hauled away? The first thing we got to do is convert feet to yards. So let's go ahead and convert this 90 foot by 60 foot by 6 feet deep hole into yards instead of feet. That way we stay consistent with our units here. Alright, so I'm converting 90 feet to yards. There's 3 feet in a yard. That's why when we take our basic unit here, 90 feet over 1, we do our conversion unit of 1 yard divided by 3 feet, just like we did previously this semester. So we can see that converting this 90 feet into yards is 90 divided by 3, which basically converts that to 30 yards. Similarly, if we convert 60 feet into yards, we're essentially just dividing 60 by 3 because there's 3 feet in a yard. We wind up with 20 yards, and the same thing with 6, essentially just dividing by 3 because there's 3 feet in a yard, which renders us with 2 yards. So our solid here, our hole that we're digging, is essentially 30 yards by 20 yards by 2 yards. And you can guess it, to find the volume, all we're going to do are multiply those numbers. So our volume is our length times our width times our height, 30 times 20 times 2, which gives us 1,200 yards cubed. That is the volume of this hole that we have dug for our swimming pool. Now what we have to do is find the number of truckloads by dividing the number of cubic yards of dirt by 10 yards. And you're like, okay, why are we doing that? Let's go back to our problem. We found the volume of the hole. Okay, we converted the feet so we can find the volume of the hole in yards. Right, that's what we did here. Took that information, converted it to yards, and then found the total number of yards cubed of this hole. Okay. Now we're going to use a truck that can carry 10 cubic yards. So we need to figure out how many truckloads this is going to take because it's going to charge us $35 per load. Okay. So if this truck here is carrying 10 cubic yards, we need to figure out how many times this truck's going to have to come to get rid of all this dirt. So what we're going to do is divide this 1,200 yards cubed by the 10 yards cubed that it can take per trip. Okay, and what we see here is that when we do that with our conversions, we know how to do conversions. We did it earlier this semester. We take the 1,200 yards cubed here, multiply it times the one trip for 10 yards cubed, basically just dividing 1,200 by 10 to give us the number of trips that we have to take. So it looks like it's going to take 120 trips. 120 trips. It's a lot of trips, right? Now, we're not done yet. Remember, each one of those trips costs $35 to make. So the truck's going to charge us $35 per trip. And that's the cost to have all the dirt hauled away. So 120 trips times $35 a trip basically tells us it's going to cost $4,200 to get the dirt from the swimming pool hauled away. The dirt hauling phase of the pool project will cost you $4,200. It's a good bit of money just to have dirt moved away for a pool. Just saying. All right. Using the formula for the pyramid's volume. Okay. So let's look at a different style volume. We found rectangular volume. We actually used it to solve a real life word problem right there. Now let's look at a pyramid's volume. The Transamerica Tower in San Francisco is a pyramid with a square base. It is 256 meters tall, and each side of the square base is 52 meters long. Let's find its volume. All right. Keep in mind that the volume of a pyramid is 1/3 base times height. 1/3 of the base times height. Now remember that capital B here is actually the area of the base. And that's what it stands for. So we need to find the area of the base. Now it does have a square base, which makes finding the area quite simple here, because it's a 52 by 52 by 52 on the back side and 52 on the other side. So all we have to do to find the area of the square base is multiply 52 times 52 to give us 2,704 meters squared for the base, okay, of this pyramid. Now we're going to take that 2,704 meters squared, we're going to multiply it times 1/3 times the height. Okay, so basically just plugging it in that volume formula for the volume of the pyramid here. Going to plug it in just right there. Now, we have to keep in mind that we do have to multiply it times the height. And remember here it says it is 256 meters tall. So the height here is 256 meters. Multiply it by 256 here, and we see it's approximately 230,742 meters cubed. That is approximately the volume of that Transamerica Tower in San Francisco. Crazy. That's a big place. All right, now, so we've looked at rectangular. We've looked at a pyramid. Let's look at the volume of a right circular cylinder. We want to find the volume of this cylinder with diameter 20 yards and height of 9 yards. Okay, so what it's telling us here is it looks like the bottom shape down here. Our diameter here, the total distance across, is 20 yards. Our height is 9 yards. Now, in order to find the volume of a right circular cylinder here, the volume is pi, which is just 3.14 approximately, times r squared times h. Okay. Now, our problem here gives us the diameter instead of the radius. So if the diameter here is 20 yards, that means the radius is just half of that. That's 10 yards. Okay. All right. So we need to just plug our stuff into the formula now. So we've got pi r squared h. So that's pi times the 10 yards we found for the radius squared times the height, which is right there. So just multiplying that by 9. So we're really looking at 900 pi yards cubed, or approximately 2,827 yards cubed for this right circular cylinder. Just a simple matter of multiplication. Do it on your calculator. Let it help you out multiplying like that. Really just a matter of plugging stuff in the formula, guys and gals, and all of my students. All right, let's look at the volumes of a cone and a sphere. The volume V of a right circular cone that has height h and radius r is given by the formula V equals 1/3 pi r squared h. Okay. Now we know r is the radius of this lower circle down here. That's the bottom of your cone in this case. Could be the top of your cone if you turn it upside down and try to do it like an ice cream cone. That's cool. Okay, so remember, just R is your half here, not your full diameter, but your half of your diameter right there. Sometimes it'll give you the diameter, sometimes it'll give you the radius straight out. Height is the height of the cone from the bottom to the top, right? And pi is just 3.14, and then you have the third right there. So you have the formula for it. You should be able to plug in for it. As for the sphere, the volume V of a sphere of radius R is given by the formula V equals 4/3 pi R cubed. Okay, so sphere, just like a circle, like a baseball-ish, but smoother, like a pool cue, okay, or pool ball, right? So you have your sphere here. If you know your radius, it's just 4/3 pi R cubed, okay? Got to take it to the cube, not the square in this one. All right, so let's look at this. Okay, went straight to the ice cream example. An ice cream cone is 5 inches deep and has a radius of 1 inch, okay? 5-inch deep, radius of 1 inch. A spherical scoop of ice cream also has a radius of 1 inch. Of course it does. If the ice cream melts into the cone, will it overflow? Oh, okay, let's figure this out. Basically, what we want to do is compare the volume of each. If the volume of the cone is greater or equal to that of the volume of the sphere of ice cream, then it will not overflow. If it is less than, it will overflow. Okay, so if the ice cream will overflow if the volume of the ice cream, a sphere, is greater than the volume of the cone. Let's find the volume of each. Okay, let's find the volume of the cone first, and then we'll find the volume of the sphere, and we'll compare the two. Okay, using the volume formula for cone, it's 1/3 pi R squared, or pi, yeah, it's supposed to be an R. Oh, got a little typo in here. Pi R squared, not pi squared. Yeah, revert back to this formula, right? 1/3 pi R squared H. Hate it when I have typos. So this is supposed to be 1/3 pi R squared H. Just like I said, refer back to there. All right, so we've got 1/3 pi times R here. Radius is just an inch. Okay, the radius of both are the same. Straight from the problem. 1 inch squared times the height. The height of the cone is 5 inches. Okay, so if I approximate this out, it's going to give me about 5 inches to the third power. 5 inches cubed. Now let's look at the volume of the sphere. The sphere formula, 4/3 pi R cubed. Okay, so 4/3 pi R here is 1. So 1 cubed is just 1. So we're really just looking at 4 pi over 3 for inches cubed. So we're really looking at 4 inches cubed approximately. So the volume of the sphere is less than the volume of the cone. Okay, the volume of the sphere is less than the volume of the cone. Therefore, if the sphere melts, then the ice cream will not overflow. Little common sense there, right? If the volume of the sphere, which is the ice cream, which has the potential to melt, does melt, before you've even taken a lick, that volume is less than the volume of the cone, so the volume of the cone is still going to hold up on it. You're going to be fine. You're not going to lose any of your ice cream slurry in there. But that's just one scoop, right? Who only gets an ice cream in one scoop? I mean, I like 3 or 4 personally. But you do you. All right, surface area. The area of the outer surface of a 3-dimensional object measured in square units. Okay. Now, surface area tends to give people a fit. Okay. Surface area is different than volume. Surface area is made up of the area of each of the faces or figures that make up the actual object itself. Okay, so if we look at a cube is made up of squares. Okay, and if you look at a cube, it has exactly 6 squares in it. So 1, 2, 3, 4, 5, and 6. So top, bottoms, 1, 2. Each one of the sides, there's 4 extra sides here. So 4 sides all around the cube. 4 plus 2 is 6. Okay. The volume of each of these squares in the cube is just the side times the side, because the cube has all the same size, or all the same sides. So really what you're looking at is 6 times the volume of, the area of each of those faces. So the surface area of a cube, because there's 6 of these squares, is 6 times s squared, which is basically just, like I said, the area of each of those faces. Now, if we look at a rectangular solid, a rectangular doesn't have all the same sides. So you know your length, your width, your height for your rectangle. Okay. Now, here's how we build this. Excuse me, sorry about that. So we have, if you read the formula, it says surface area equals 2 length times width plus 2 length times height plus 2 width times height. The way it builds that up, let's start with the 2 LW. Now, LW makes up the bottom and the top for the area of those figures. So length here are the long side, so this is essentially the same L, right? And this is the same W here, which is the same W right here, which is the same L on this side and the bottom side, right? Now your H is here. This is a W. This is an H, and this is an H. So you can kind of see where everything plays. Okay. L and W make up the top and the bottom. Okay. The top and the bottom rectangles that make up the rectangular solid are your L and your W. There's 2 of those. So 2LW is going to give you the surface area of those 2 parts. 2LH, LH is the front and the back of this rectangular solid. Okay. So LH, we have 2 of those as well. That makes up the area of those 2 faces. Okay. And we still also have a WH. WH are the 2 sides. Okay. The 2 sides are made up by this 2WH, which gives you the surface area total if you add all 3 of those options together. Basically just adding up the area of every single surface on that particular solid. Okay. A circular cylinder. Okay. Surface area here is 2 pi r squared plus 2 pi rh. Okay. What we're looking at here, you got 2 pi r squared, okay, which basically is going to give you the surface area. Pi r squared is the area of a circle, which gives you the 2 circles. Which gives you the 2 circles, the one on top, the one on the bottom. 2 pi rh. Sorry. Is going to give you the area of the exterior here, because that's going to make up this like prism kind of thing here. Alright, let's put them into practice. Oh, that sneeze messed me up. Let's find the surface area of this rectangular solid. The length is 8 yards and the width is 5 yards. And the height is 3 yards. Okay. Now, we're just going to use this formula. Surface area equals 2LW plus 2LH plus 2WH. Okay. And all you really have to do is plug your options into this particular formula. Okay. Using the figure. 5, 8, 3. Okay. So here I've got 2 times 8 times 5. That comes from 8 times 5, so your bottom and your top. Plus 2 times 8 times 3. 8 times 3 is your front and your back. 2 times 5 times 3. Those are both your sides. Okay. Do your multiplication there. Work it out. You basically get 80 yards squared plus 48 yards squared plus 30 yards squared. You add all the areas of your sides and stuff together, and you're going to get 158 yards squared. Okay, it's just a matter of breaking it apart. Like I said, you shouldn't be going near as fast as I am as I talk through this. Really what you should do is you should see the question before you even start and look at the solution. You should try to work it by hand by yourself. See if you get the same thing. If you don't, watch the explanation. Try it again. If you still don't get it, watch the explanation again and try piece by piece to see where you're missing out at. Write your work out clearly, and let me know if you have problems after that 3rd attempt. Now, you can use any of these surface area formulas, but depending on the figure that they give you in your homework. You know cube, you know rectangular solid, you know circular cylinder. They have all these here. It's just a simple plug it in and solve it out. Plug it in, solve it out. Rectangular solid, like what we just did, we plugged it in and solved it out. If it had been a cubed, we would have just plugged it into this 6s squared and solved it out. Okay. Don't be intimidated. Take your time with it. Write your work out neatly. Use your formulas. Plug it in, solve it out. Write down your formulas right now so you'll have it with you when you work your problems. Plug it in, solve it out. If you have any questions or any issues, Feel free to reach out to me at any time. Hope that you enjoyed this lecture, and I will see you next time.